Hello again. Um, this video lesson of section 1.2 is going to cover functions and their properties. I guess you can read that, but mostly just the terminology associated with functions and the things we need to know when dealing with them. First of all, the definition of a function, as you see, is a rule that assigns every element of one set, D, called the domain, to a unique element of set R, which we call the range. The operative word here is unique element of the range. So we'll see how that comes into play in just a moment. Take a look at two representations, A and B, and try to determine, based on that definition, which of these represents a function. The tan set would be the domain, and the gray set is the range. Which one represents each element of the domain being assigned a value in the range, a unique value in the range? I hope that you chose B as, A is a function, B is not a function. If we look at the domain element x1, it's being mapped or paired with y1, but it's also being paired with y3. So it is not assigned to a unique element of the range. When we look at a relationship in graphical form, the horizontal axis is the domain and the vertical is the range. And so considering that, can you determine which of these three is not a function? I hope you answered C. If we look at this part of the graph of C right here, we could see that if x were 0, y could be 0, or if x is 0, y would be 2, or the point 0, comma, -3 would all be on the graph. So C is not a function. That last example was a demonstration of the vertical line test that you remember from Algebra 2, I'm sure. It states that a graph of a function in the xy plane where y is a function of f, if and only if a vertical line intersects the graph at no more than one point. So pass the vertical line through the graph, and if it intersects that vertical line at more than one point, it fails the vertical line test. So, given the discussion so far, what would be a solid definition for the domain of a function? I hope you said something like this: all the possible input values of a function, or all possible x values. Something like that. Well, now that we know that what the domain is in words, what does that mean? If f of x is described as the square root of x minus 3, what would the domain of that be? How would that domain be restricted? I like to say sometimes, what values of x cannot be in the domain? Well, we know that you cannot take the square root of a negative number. So any value of x that makes the radicand negative would be kicked out of the domain. Or we say that the radicand x minus 3, pardon my writing with a mouse, it's a little sloppy, has to be greater than or equal to 0. And that little bit of algebra, we'll say that x's must be greater than or equal to 3. And I'd like to introduce a way of describing that set of numbers called interval notation. Interval notation, we just express the interval. Let's look on a number line. This is a little messy, but bear with me. I'll put a 0 here and a 3 here, and just show you that the interval of numbers would be all of the numbers over here to the right. I'm just shading this, okay? All of these numbers are in the domain. And at 3, it's in the domain as well, so I want to make sure I recognize that by shading 3. So that's a graphic representation of the domain. And in interval notation, you always list the left boundary of the interval. This interval is from 3, and then the right boundary, well, that's all the way to positive infinity. And since 3 is in the set, we use a bracket to indicate that. And the infinities always take a parentheses. If this were the interval x is greater than 3 and not including 3, we would use a parentheses instead of the bracket. I'll go into this more as we progress. So to express this, we say the domain is the interval from 3 to positive infinity. Okay, so how about this one? Is this domain restricted at all? Could x be any real number, or is there any restrictions on it? When we have a ratio, a rational function, that's what you call it when you have a ratio bar or a fraction bar. The restriction on the domain would be anything that makes that denominator 0, because division by 0 is undefined. So I'm going to pause. I want you to pause this and see if you can figure out what values of x would make this denominator 0 and restrict them from the domain. Well, I just said that denominator cannot be 0, so I'm going to set it up this way. Set the denominator minus x minus 6. Find out what makes it 0, and then kick those elements from the domain. If we remember to solve this, perhaps it'll factor. It looks like it might. Let's see, we've got x, and the factors of 6 are 2 and 3. And we have more negative than positive. So it's factored. The zero product property says that the x plus 2 could be the 0, or the x minus 3 could be the 0. So x equal negative 2 or x equal positive 3. These are the two elements that must be restricted from the domain. Okay, so we found the two things that are restricted, the two elements restricted from the domain. Let's see what that looks like. Let's see if this is negative 2, and here's 3 on the number line. That divides the real numbers into 3 intervals. All the numbers that are in the domain would be all the numbers that are on this side of negative 2, but not negative 2. Make an open circle. All the numbers on this side of negative 2 all the way to 3, open circle. And then the last interval would be from 3 to positive infinity. And the way we write that would be negative infinity is the left boundary. It takes a parentheses. And negative 2 is the right boundary of this first interval. And negative 2 is not included. And then we have the interval from negative 2 to 3. And 3 is not included. And the third interval is from 3 to positive infinity. And it always takes the parentheses. And we say that the domain would be equal the union of these 3 sets. This is 3 distinct sets, and then we put the union symbol in there. All right, so spend a moment and think about how you would define the range of a function. If you've got a definition for the domain, the range should be very handy. Take a moment and write that in. Well, since the domain was all possible x values, the range then is all possible outputs of a function, or the y values, all possible y's. And I know you probably wrote that as well. We can ask now the question of domain and range for a given function. Finding the domain of this one is easy. There's no restrictions on squaring any number. Any number can be squared, so the domain of f is all real numbers. What does that look like in interval notation? Well, all real numbers would be, what's the left bound of all real numbers? Negative infinity. What's the right-hand bound? Positive infinity. So an interval notation is like that. And the range. So what are the output values? When I square any number and then add 3 to it, well, it's going to, I know the right bound, the upper bound is always going to be infinity. But what about the left bound? What's the minimum value of this? The smallest possible value for the output, for the y, would be 0 squared plus 3. So the range would be 3 to infinity, including the 3, so we put the bracket. Now let's have a look at a graphical example. Let's pretend like this is the graph of a function f. I don't know what that would look like mathematically or algebraically, but it's a graphical representation. Can you determine the domain and range of this function? So take a moment and enter your values. Enter your values in interval notation. I hope you saw that the domain, all of the possible x values, well, they run from a minimum of -15 all the way, well, it goes to -5 and includes it, but then picks up again here, and -5 is excluded, but it was included here. So this function is continuous on the domain from -10 all the way to +20. Excuse me, -15 all the way to 20, but -15 is not in the domain, so it takes a parentheses. The range of values, all the y's, well, if you look at the y's, the smallest y would be -10 right here, and it goes all the way up to +10. All y values are included from -10 to +10. The -10 is included, but the +10 is excluded, so it takes the parentheses. And so that's a reasonable refresher course on functions so far. We have a few more things to talk about with functions, but I'm going to do that in a separate lesson. So I'll see you in class tomorrow, ready to work the exercises.